So I'm Anand Kulkarni. I'm the CEO of a company called Crowdbotics. We are a company that uses combinations of crowds and machine learning to build software faster in ways that we think will be interesting. Prior to this, I ran a company for many years called LeadGenius, which was a private, verticalized crowdsourcing platform. Before that, I was at Berkeley. So a little bit about how I got into this space. Started a company called LeadGenius when I was in grad school with 3 other PhD students at the time. LeadGenius was a private crowd labor engine. So by crowd labor, I'm referring to systems that are like Mechanical Turk or Upwork, but this was private, meaning that you couldn't sign up and post any kind of work you wanted to. You could only do one kind of work. It's used by non-specialists, so you didn't know that you were using crowds when you used it. You actually thought you were buying a sales product. But behind the scenes, everything that was happening was crowdsourcing. We were venture-backed. We raised about $20 million in venture funding. The company is still going strong, employs about 50 people in downtown Berkeley, still close to home. It also employs about 500 people worldwide, which was an interesting goal of the company to try and create employment at large scale and attack poverty through crowdsourcing. And we're still successful at doing that. We pay about $4 million out a year to base and middle income communities around the world. Started a company called Crowdbotics late last year to apply some of the same ideas to software engineering. I also do research, and both these companies are spin-outs of the research that I've done in crowdsourcing. I'm interested in 2 questions. The first is how we can build crowd platforms that are fairer, that try and create more equitable relationships between people who are doing the work and people who need the work done, how you can use them to address issues around unemployment or income inequality. And then also this question of how you can create more complex things, artifacts, outcomes as a result of crowd work. Okay, so what is crowd computing? Hopefully some folks in here have an idea. Is there anyone who wants to take a stab at a definition? And I won't allow Lydia or Michael to do it.
Everyone fails.
Okay, well then Lydia and Michael, I'll open it up to you guys.
Well, for me, it's part of, so the crowd part of crowd computing is where you use a group of people that may be fluctuating, maybe you don't know them all by name, maybe you haven't, so something about them that's slightly anonymous or open-ended. And then the computing part of it is getting them to do things in a computational, systematic way.
Yeah.
Rather than just the normal way of just throwing a bunch of people together and telling them, you figure it out, to put more structure on the process.
Yeah, so I think that's a terrific definition. Informally, I sometimes characterize it as how do we get groups of strangers to do stuff that we want them to do over the internet. But I think the remit has actually been transformed recently, and it goes into a much more expansive view in the way that you're describing. So Rob Miller at MIT used to talk about this definition of crowd computing is how do you get people and computers to work together to achieve things that neither one can do on their own. But the modern definition that I like is, I got this from Walter Lasecki at University of Michigan, which is computational management science. How do you program teams of people to do things that are cool, interesting, hard, difficult? And that covers a pretty big spectrum of things. So some examples of this that we may or may not recognize as crowd work at first glance. You have systems that are true virtual labor, things like Fiverr, which is a simple platform to pay people a small amount of money to do a thing for you. You have Upwork, which used to be Odesk, which is a system for hiring people over the web to do freelance work. And then you have pieces of work that are really small, micro-task platforms like Mechanical Turk. And these are systems that are software, where software assigns the work to be done. They're done virtually, and people will actually carry them out online. So they send you work digitally in response. Then you've got systems that are coordinating groups of people in the real world, where they're physically executed, but the algorithm is dictating who's going to do what. So Uber and Lyft are our favorite examples because you have lots of crowd workers who are showing up and doing things on demand. And there's software layers that are mediating the relationship between the requester of work and the executor of work. But that also includes systems like Instacart or TaskRabbit, where people are being dispatched out for gigs by a software system. The other end of the spectrum that I think is starting to get eaten, starting to be eaten by crowd work, is this idea of non-software contract work. So you can imagine hiring a freelance writer or a freelance consultant, or maybe just getting somebody to work for you for a few hours as a favor. That's also a form of crowd work, and we don't always recognize it as such.
What isn't crowd work?
If you have a job inside an organization. So that's...
They may use computational means to schedule my work or give me tasks or
They should.
use my calendar. Is that not
I think
the definition?
I think that there is a process we're seeing here where crowd work is getting consumed, or what we might think of as traditional work is being eaten away. As more and more computational processes get involved in our day-to-day jobs, those start to look more like large-scale crowd work. But the strong relationship that you have with your employer is usually what differentiates it. So this is the trend that I'm alluding to. Technology-mediated crowd labor is starting to eat away at conventional employment in lots of ways. According to Pew, about a third of Americans, maybe less depending on how you define crowd work, worked in the gig economy in some form last year. So there's a feeling that combined with automation, this is going to affect conventional employment in some ways. Even expert jobs are probably going to be affected. We have seen a trend in the crowd research community where more and more tasks that we thought that could only be done by an expert can be done by teams of people plus some software who are not experts. So this is something that we have to watch and think about. In the research community, we've seen an interesting trend in crowd research in the last few years. Back when we started 10 years ago as a crowd research community, we thought about crowd work as micro work, stuff you'd do on Amazon Mechanical Turk or Games of the Purpose, really tiny tasks, right? Things like reCAPTCHA by Louis Von Ahn at Carnegie Mellon, where you'd do something that was really, really short. You'd have a lot of people do it, and you could parallelize work in a very big way. Recently, we've got stuff that's about 5 years ago where people were interested in chaining together microtasks in interesting ways to design workflows, things that were taking complex activities and breaking them out into sequences of chained tasks. Nowadays, last couple of years, we've seen good work, some of it at Stanford, some of it elsewhere, looking at how you can think about crowd work as programmatic collaborations for complex tasks. Things like producing a video, producing a software interface, using teams in interesting ways. So this trend of increasing complexity is showing where we're going as a crowd research community, but it's also being reflected by the kinds of things we're seeing on the industry side, which is where I spend most of my time. So 10 years ago, you had a bunch of these platforms that were basically open-ended labor platforms that were handling simple microtasks. Mechanical Turk, Odesk, Elance, Freelancer, Crowdflower, they were all built for simple work back then. 5 years ago, you had companies emerge that took advantage of these workflows to productize a sequence of human activities with some software layers on top that made it look like it wasn't a crowd that was doing the work and allowed people to buy it and use it really easily. So 3 examples are Captricity, which was also a Berkeley spin-out, which allows you to use Mechanical Turk without knowing you're using Mechanical Turk to digitize lots of documents. Rainforest QA, which I'll talk about in a little bit, uses Mechanical Turk at large scale to automate software testing, and LeadGenius did this for sales and marketing. Recently, we're seeing a new trend. The kinds of companies that are being formed nowadays around crowd work look more like the kind of research projects that people are trying to come up with on the academic side, where people are coming up with complex software systems that are mediating with each other to, or that are mediating the relationship between buyers and sellers of work in advanced ways. So B12 is a good example, which is working on trying to crowdsource the software design process. Systems like AngelList are modifying the transactions that happen between groups of very specialized crowds, investors and companies. And then Crowdbotics is thinking about this in software development. Okay, so today I'm going to talk about 3 things. And so we have a little time for discussion. I'll make sure that those the discussions here are short on each one of these. So first I'll give you a little retrospective on LeadGenius, which was the large-scale verticalized crowd platform that we built. Tell you a little bit about how we developed that. Then we'll jump into Crowdbotics, which is our project today to write software with crowds. And last, I'll close with some big open challenges that I think are interesting for us to look at as a research community. Okay, so we'll start with LeadGenius, and its previous form was a system called MobileWorks. So 2012, along with Bjorn Hartman and Tap Parikh at Berkeley, my co-founders and I started a company called MobileWorks. We were a non-marketplace architecture for accurate human computation. If you look at that title, you can see the kinds of things that we cared about as crowd researchers back in 2012, which was accuracy and how you could avoid marketplace dynamics and the negative repercussions of those dynamics. If you've used Mechanical Turk, you may remember a time when the biggest challenge was quality. And back then, we used to think about crowds in a way that is not very popular today, thanks to the work of many people in the crowd research community. We used to think of the crowd as basically bandits who are out to trick us, right? These folks who are showing up, we don't know who they are on a crowd research platform. They're anonymous, they're transient, they show up, they take our money, they disappear. They don't have much skill, they don't have much engagement, and a lot of the systems that we built back then were designed to try and combat those trends, to try and make sure that people were forced to be honest or forced to, they were prevented from cheating us in some ways. So we rejected that view as part of the thesis for building our crowd platform. We had this idea that you could get better results from a crowd marketplace by setting up a system where you treated workers like real people who were coming back over and over again, driving engagement over time, and trying to recognize them as humans, which of course is a very natural approach if you come from that universe.
Yeah, so just to push on the definition you were thinking about earlier, the returning repeatedly sounds more and more like a traditional employment relationship. So are you making it not crowdsourcing?
Mm-hmm. Yeah, that's a great question. So in fact, if I had to give a critique looking back on what we were doing in LeadGenius and MobileWorks, I think a lot of the choices that we made and the reason we got good results in working with our crowd was that we adopted many of the paradigms of a traditional organization. And you'll see that we did many of the same things that incur a lot of overhead in a real organization, like having management structures in place, like having performance reviews, like having peer relationships. We did do those things via software, as opposed to doing them via informal mechanisms or social conventions. But I think we adopted some of the best practices from real-world organizations that made us less like a crowdsourcing flat marketplace. But it's also why it worked. Yeah, so if I had to expand on this, we talked about this idea as good work, that treating workers fairly would lead to quantifiably better outcomes. I think a corollary on that, based on your point, Michael, is that treating workers like they are treated in a real-world organization leads crowd workers to behave better and yield better results. So there were some insights in there that were useful. We had the best workers in the crowd become managers. They would supervise and teach the rest of the crowd. So it stopped becoming a totally flat marketplace very quickly. We would actively assign tasks to members of the crowds. We wouldn't actually treat it as totally as a marketplace. We would make sure work got done because we'd pick out who should get the work and say, you're doing this job today. We priced automatically. We set a price floor in the system. We said everyone gets a minimum wage, and that made our workers very happy. So that management model looks much more like a real-world organization. The people who were working for the crowd were divided into teams. They had teams of 2 or 3 at the bottom who rolled up to team leads, who rolled up themselves to managers, who rolled up to super managers. And at the end of the day, everyone reported up to one person in our office who was managing a giant crowd of lots and lots of people. It was not me, yeah. And that was by design as well. We actually had specialized roles that developed over time as well. People who were QA, people who were interviewers, who were just tasked with evaluating other members of the crowd, people who were HR and tasked with determining if people were meeting their metrics or not. And I think many of these roles could have been done in software. We just chose not to. And we had this nice system that we had built for managing all of this via a software model. So we had a virtual office where people were continuously chatting with each other, looking at the performance that our system assigned to them, and allowed the crowd to interface with each other in terms of supervising, hiring, firing, things like that. So one of the cool activities that we did here that was extremely effective, and far more effective than I would have predicted, was to simply put workers into a peer relationship with each other, where they could chat and talk about the work they were doing. Historically, in microwork, there was an attitude that you should try and keep workers separate, and part of that was forced by the dynamics of the mechanical Turk marketplace, where workers would experience the system in isolation. Here, workers were permanently put into persistent chat, where they would discuss with their teams or with their colleagues different projects they were working on, which allowed us to do a lot of quality control before we even had to get to a software question. So you can see here 2 examples of situations where workers were either talking to a superior worker, somebody who had been given status in the system, to diagnose a question, or a situation where somebody had an issue with an actual project they were working on, they didn't know the answer to, and somebody else was able to address it. And you can see here also that this allowed us to do things that we didn't expect. There's a conversation happening here in Russian, and nobody in our organization spoke Russian, but we were able to successfully carry out the work and recruit a fairly large Russian-speaking community that was required for this project because we had peer support systems in place. So everybody in these chat threads is a member of the crowd, as opposed to somebody who's working for the company in a firm employment relationship. And actually, this model had a bunch of positive side effects too, right? Like late last year, 2 of our workers got married to each other. One was in the Philippines and one was in Serbia. So a very long distance relationship mediated entirely over that chat interface, which was an interesting dynamic. And there's been some great research done by Mary Gray and Sid Suri at Microsoft, looking at the LeadGenius community in particular, as well as a few others. And if you're interested in some of these dynamics, I'd encourage you to read it, because she spent a lot of time with both our community of workers and a few others to figure out what was working and what wasn't.
Does this mean you also had to deal with workplace harassment issues? Mm-hmm. Like this is the benefit, but it also means that you're assuming some of the liability.
Yeah. So it was very interesting because we had to walk a fine line at times between treating the community as an online community, which was not officially part of the company. In some sense, they were medium engagement users of our product, and people who were doing work through our system for our customers. And balancing that line, it required us to do a few things. So a lot of the support and the grievances and the resolution of the problems that were experienced had to be pushed back to the community and saying, okay, you guys are going to figure out ways to resolve these. Here's resources that we recommend you use to resolve these issues. Harassment did come up at times, and we saw situations where people were sometimes bad actors. We worked out ways to expeditiously remove those individuals before they got into the system, and we got pretty good at it later on. There was a complex interview process that we'll get to, where we got to screen through a bunch of people very quickly. So just to sum up on this point, MobileWorks MobileWorks and LeadGenius basically were on the other end. They were what we call a managed crowd. They were on the opposite end of where we thought we would end up, which was in microwork, per task pay, and so on. So we did work on this question as well, which is worth mentioning, which is how you can get people to escape poverty or improve their standard of living using crowd work. We did have an hourly wage that was supported by the World Bank. We pulled people from historically underrepresented or underemployed communities, and we tried to work on productivity measurements that would keep people honest during that model. Tended to work out okay. Okay, so how do we find good workers? So we basically had 3 approaches. First one was web search. People would just discover us on the web. That worked okay. We got much better workers by just asking the crowd to recruit other members of the crowd that could join. Turned out to be phenomenally effective, and we'd pay them bonuses and treat it like any other task in the system, which was cool. We also worked with a bunch of nonprofits and government agencies who wanted to get employment for their communities. So I went out to Jamaica with the World Bank to try and talk about how crowd work is an interesting way to find economic opportunities. I still think that crowd work is a great economic enabler in many parts of the world. You can see there's another one of our teams in the Philippines looking very happy because they worked for us. Okay, so once we had this stream of people coming in, we basically put them through a 3-part test. They'd actually carry out a small task, information retrieval usually, so we could verify that they were able to read, interpret instructions, respond to them. We'd give them have them do a writing sample, like a situational challenge. We'd have them do an audio sample, another situational challenge. And then if they got through all of that, so here's an example, right, of the actual LeadGenius test. They're given questions with grammatical errors in them, and they have to find the error and fix it. So all this was automated, and it made sure that we could actually get people who could follow and interpret instructions really well. And we got to about an 8% accept rate for people who tried to take this test. So it was a pretty broad stream of people we would filter through to get our actual workers. The final step would be an actual human review of that person. And we didn't interview them ourselves. We had somebody in the crowd who was known to be good interview those people. And that allowed us to maintain a pretty high level of quality going forward. And of course, after they were hired, the software would monitor them, their peers would monitor them, and so on. And it would look something like this. You'd have a nice, pretty stream of various activities and reviews that they'd done over the course of some time. In addition to that 8%, we also had about 1% of the community who we'd fire every month. It was involuntary, usually not people who said, hey, I'm leaving, I don't like this anymore, but people we'd say, you're not meeting the criteria, we're going to filter you out. Cool. Okay, so I'll tell you a really short story about how we went from this open-ended crowd platform into LeadGenius. We started out thinking we would replace Mechanical Turk. We were wrong. Mechanical Turk was not nearly as big as we thought it would be. We did a lot better just by going from trying to compete with Amazon Mechanical Turk's small $5 million market size in 2011 to a product called LeadGenius, which basically took that crowd that we had built that was highly effective and carefully screened and turned them into a lead generation engine. What that means is we would carry out this one particular task, which if you follow the crowd literature is sometimes called CrowdDB, which means somebody asks you for some large-scale amount of information that doesn't exist in any one database. You look through a lot of different databases to finish that query. So for example, if you're a salesperson, you might come to LeadGenius and say, give me every company in Brazil that purchased online ads in 2014, and find out the director of marketing of each of those companies. It's a pretty complex query. It's got multiple pieces of information that are stored in different systems all over the web, all over public databases, private databases, government records, and so on. You can use crowds very effectively to stitch that information together, especially if you have crawlers that are pulling out information from sources all the time. So that was LeadGenius, where we ended up in a nutshell, and that's how we got this thing to scale up super fast. We generated tons of work just around this kind of activity. Salespeople would use it. They wouldn't need to know anything about crowdsourcing. They wouldn't need to know anything about our beautiful model for fair worker treatment. This allowed us to generate lots and lots of work. And the product is great. If you are a salesperson, you should still use it. And basically the idea here was the trend that we're talking about. We took a project that historically had been done just by a person, a low-level salesperson inside an office, and combined it with crowds and software to basically take it off of people's plates. So there's a role inside sales organizations called sales development representatives. And historically, their time had been spent looking people up on LinkedIn, right, or cold calling people, which is a not very effective use of somebody's day. We basically replaced that with a productized crowdsourcing flow called LeadGenius, which allowed them to focus on higher value activities. Didn't mean that you'd put everybody out of work who was a sales development rep. It meant that they would just spend a lot less of their time digging up information. And yeah, that led to a steady supply of work from people who didn't need to know what crowdsourcing was. So it worked pretty well for the actual goal of LeadGenius that we started with, which was not to build a sales product, but rather to figure out ways to generate employment for a bunch of people who were in a crowd. And that's our quarterly worker payout for the last 4 years. And it's getting up there, right? We do about $4 million a year right now, I think, in worker payouts, maybe a little more now. We had great results in terms of the social dynamics on all of our social impact studies. We were trying to ask if we could actually impact people's lives. Generally, our surveys said yes, although these weren't scientifically great because we ran these sort of internally. About 70% of our community didn't have a job before they found us. 85% of them were supporting one or more children. So this was basically supporting families. And about 10% of them were single mothers. And today we're paying out about $4 million a year. Did a bunch of surveys, got a bunch of fan mail too. We bundled a lot of this into a movement we started last year with Pollock Shaw at the National Domestic Workers Alliance, which was this thing called the Good Work Code, where we tried to rally a bunch of crowd labor platforms and crowd labor users to commit to doing honest, fair treatment of their communities. And it's gotten some momentum behind it. So there's been a bunch of signatories so far, although of course we don't have Mechanical Turk or the big guys. Yes.
Do you have any data on whether this kind of work leads to some of those people who didn't have a job before getting skills that lead to them moving on to other kinds of work?
Yeah, so we actually thought about this question a whole bunch because we, in the beginning, thought that this would be a great trajectory and a great outcome, that we would graduate people into the traditional economy. Unfortunately, there's a perverse incentive for crowd labor companies. Once you've trained somebody to be really good, you don't want them to leave. You want them to keep working for you. And it wasn't actually an effective outcome for them if they went and joined some other company. So we didn't track this data, so I don't have information about that. We did track a different system, a different metric, which for us was internal mobility. We would promote people inside the company from being a junior team member to a senior product manager, or senior project manager. And we actually, some people were so good we hired them in our office in our core team. Not a lot of them, but many of them. Made that trajectory. So that was interesting to see.
One of the possible perverse incentive I'm curious if you have any data on is what the upward mobility opportunities were within your company versus the ones that would have been surrounding them had they left the company. For example, if they got promoted within your company, were the opportunities there simply better because you were willing to commit to this good work code than anything they could have gotten outside?
Yeah, that's a really interesting question. So part of our market strategy was targeting communities where people did not have good employment opportunities based on their current skill set in their community. So a good example would be we worked with a number of Muslim women in very conservative communities where they were not encouraged to leave the home for work. They were fantastic for us because they didn't have alternative opportunities, and they were able to develop quite a strong reputation inside our community that couldn't be exported outside for reasons that were outside of our control. I suspect that if you wanted to build a model like this that was large scale enough to, and your goal was to try and transition people off of your system, you could do that. It would be an interesting question to ask, how do you link them up with the just enough skills that they're useful and you can push them out to somewhere else?
Use your own system to generate leads for them to pursue if you get jobs.
Actually, you certainly could.
You talked a little about like people having this hierarchy where people then become managers. That was true within LeadGenius as well.
Yeah, so that was the LeadGenius model.
Okay, good. I'm glad I've been paying attention. I feel like the nature of the Leaf work in terms of time commitment is very different. As for myself, as a grad student, I could kind of work whenever I wanted. If I was having a terrible day, which never happened, I could, do that. But then as a manager, I had to be on all the time. And were your people in your crowd able to make that that transition in like the structure of their day?
Okay, it's a fantastic question. So one of the dynamics we had, one of the design decisions we had to make early on was the question of the level of engagement we would expect from the community. Because as you know, you've got on crowd platforms folks who are treating it more like a steady full-time employment where they're committing eight hours a day or more. And you've got a large community of folks who are just freelancing part-time for fun, who are carrying out unstructured tasks. The latter community is really useful for a crowd platform because they introduce liquidity. They show up whenever you want, and they go away quite happily. They are not great if you're trying to build an organization over time. It's because they're unreliable, they disappear. So, in a perfect universe, everybody is a full-time manager, right? Or willing to work like a full-time manager, and nobody is sleeping in and showing up, doing a few things and disappearing. So we ended up biasing our system in the same way to prefer that model. So in our model, everybody was acting like a manager in the sense that we would require them to work a minimum of 20 hours a week if they wanted to join the system. And we had enough inbound interest that we would be able to maintain enough of a community, even just taking people who had 20 hours a week of availability or more. The overwhelming majority of folks preferred to work 30 or 40 hours a week. I will say, though, that that time was somewhat unstructured. So they didn't have to do it all at a given time if they wanted to. Cool. So I won't go too much into the good work code. You can read about it online if you want. There's also the Future of Crowd Work paper, which talks about more or less the same issues. How you can make crowd platforms that are ethical, that are fair, that are honest, and so on, that treat workers fairly. We rated our community rated us on these different dimensions along the good work code. There was some that we were exceptional on. There were some where we needed to do some more work. So these kinds of surveys on crowd platforms, I hope, become more common so that people who are designing platforms will think about the design directions they need to improve on. So that's how we use this data. We basically use that to decide where we should focus our development efforts to try and improve our system. And here's a sample of this data, right? We asked about pay rates a lot because this was a question we grappled with mightily at the beginning. How much do you pay people for a given piece of work? We looked at World Bank surveys. We looked at published rates for poverty data. And okay, most people thought their work was fair, but everyone wants to earn a little bit more. And that's an area that I think, could do some more thinking on. But of course, we got a lot of fan mail too. That's fan mail from one of our workers. They thought this was better than a job cycle, even though they were being a freelancer and working online. They actually thought this was worth doing. We did have good cases of people who actually used this to basically guarantee income security. And a lot of people reinvested in their families. So there were some feel-good stories in there, which was nice. Those are all community members, by the way. Great. So next up, I'll talk about the new company, Crowdbotics, which is answering this question of how you can write software with crowds. I want to leave some time for discussion, so I'll be direct on going through this, right? So the motivation for this company was that a couple years ago at LeadGenius, we started seeing this funny thing happening with this community that we had built of people who were doing effectively online database research for us. We'd built this interface to put data in, which was basically a form. And our community would use that all day to enter data about companies. But they didn't use that. They actually ended up using this interface, which we hadn't built. This was built, this sort of showed up in the wild, and we were really confused that this thing had emerged for what we thought was a pretty specialized task. On a private platform, that somehow somebody had come up with another interface that was arguably better than ours in a lot of ways. Same thing happened with our database research tool that we had built. We had an internal database of lots of companies. You could research it. People didn't use it. They instead were using a custom Google interface that somebody had put together. Okay, so this was really surprising because we had a core engineering team who had been building product for a long time, and we'd spent a lot of time building this stuff out. And people were just sort of showing up with these tools in the wild that were making their lives better. So we were trying to figure out what was happening. What it turned out was that people who were in this community, in our crowd, happened to know how to program, and they just built their own interfaces for trying to make their jobs easier. We didn't ask them to do it. They just showed up and did it. This was really a surprising turn of events for us because we had a community here that was basically earning enough money to provide income security. They were doing work that was not designed to be highly skilled or specialized, but they were able to do work that we considered very specialized, which is software development. So here's the two people who actually built those two interfaces in particular. We went and tracked them down to find out what was happening. One was a computer science student in Kingston, Jamaica. One was a mother living in Colorado. They were... they both told us the same thing, which was that they were ambitious, they wanted to learn more about technology. Sometimes they had technology experience or programming experience, but they couldn't get job opportunities to be a software developer in the communities they lived in. There just weren't enough opportunities for people with that level of skill. And so you could probably, I'd speculate that you could probably say something like this, that for any big enough community you look at, some portion of those are going to be experts in something, especially software development. Okay, so we built this model, which actually worked out, which was we took those folks and said, instead of working for $5 an hour entering data about leads, why don't you just work with us on software development? We'll pair you up with one of our software engineers in-house. You guys will work together, and we'll see what will happen. So before we get into Crowdbotics, I'll tell you what happened here for us. And we'll skip over the sort of the long story here and tell you about how it worked for us. Okay, so skipping into this. Okay, so we basically tried two things at LeadGenius, right? One was this idea that we would have the crowd design and build their own stuff completely from scratch, right? So we said, hey, we're having you guys do this activity, which is entering leads, and you guys see the interface that we've got. You know how our system works. Come up with your own ideas for how you're going to build these tools and give them out to us. Like, we'll look at what you've come up with, we'll give it a fair shot, and we will decide if it's if we like it enough to actually use it. So we didn't give them access to any of our internal systems. We didn't try to teach them how to write code or tell them what we wanted. In that first approach, we just let them do whatever they wanted and said, we're going to take a look. Open call for contributions, right? In the second approach, we actually invited people to install a copy of our code. So this was like would have been a big security breach if it had been a big company, but we said, let's just see what happens. We let them mirror our entire code base, train with one of our engineers, and actually work on making contributions via GitHub. So they would actually try to write code that we would ask them to write out. And so this was a one-to-one matching model, right? We'd have an apprentice in the community, and we'd have an engineer in-house, and they would work together to build code. Okay, so started out with these two experts. We used those experts to find more experts. We used a technique that was called the crowd search, which was in a 2014 HComp paper called WISH, which you can look at if you want to learn about that algorithm and how it worked. The short answer is basically you have experts ask around to find other experts. That's the sort of the tiny example of how it works. We did get a bunch of other experts. We found people who had built stuff like this in the past. Some of this is material that we wouldn't consider particularly good design, but the code was clean, and the experts attested to the code being clean. So we said, great, you guys are going to be the experimental community for this. We found 6 people plus those 2, so we did this experiment with 8 people back in 2015. We tried these two models with this small community of folks. Okay, so first strategy was open call for contributions, just with the incentive of people improving the work platform. Didn't give them any specific directions, just said, what can you come up with? Okay, so this actually worked. That was kind of interesting. People did not do this for the money. We didn't actually offer them specific pay for it. We just told them that we'd give out their code to other people if we liked it. People contributed projects in Angular, JavaScript, and also reconfigured public interfaces on other tools to make them more usable. All 8 of those folks came up with new ideas that were interesting. we probably don't think that's that surprising because expert crowd users should be able to come up with new ideas for how to improve a system. They proposed 3 kinds of things: workflows, improvements to specific features, and ideas for new features. Some of those were actually useful, some were less useful. The crowd was much better at doing this when they had more experience in a given interface or product. They also tested this stuff a lot more than we did with the community, which was something that was interesting. So if it was a project that the crowd had actually been working on, a member of the crowd had been working on in the past, they actually had better insights and they were more willing to shop that to their own, the actual users of the system than we were. And that's because they were embedded with that community every day. Okay. So this was actually interesting for us. We treated it as basically a rapid prototyping tool. We did not use their code out of the box. We ended up rewriting it all. If we liked the actual results, then we just rebuilt it from scratch. We built a Chrome extension this way and a few other tools. And this was pretty effective. It could work for target problems, but it was mostly just an efficiency gain for us. We needed new ideas. We asked for an open call for new ideas, and expert engineers could come up with it. So that's cool. Okay. The next model we tried was centrally directed contributions. And this model was very interesting because it's much more like the model that we ultimately ended up using. So in this one, we actually took members of the crowd, we paired them up with individual engineers in the team, and we said, you're going to be a mentor to this person, and you're responsible for their performance. So they would communicate over email, over HipChat, and over GitHub comments. So these folks had system access. They were basically like interns joining the team temporarily, except they had been pulled out of the crowd using this search model. Okay, so we actually tasked them with specific issues in GitHub. So we'd say, here's the one you're going to own. Go do it. They'd get notified, go write the code, submit a pull request to us. We could have been more sophisticated here. We weren't because we were just prototyping this thing out to see how it would go. Then the developer in-house would actually review the results and commit it back in. Okay. So successes. First time we tried this, the great thing was we got a lot of code committed and a lot of code built. Okay. So that was the upside of this intuitive approach. In fact, we got 20 commits out of those crowd members into production code. So each of those folks contributed 1 or 2 things on average into our code base. They were highly motivated. So we asked about skills trajectories inside organizations. People who were doing this were working in some cases for the first time as professional software engineers in any capacity, and somebody was giving them a shot for the first time. So they liked that, and they liked that a lot more than they did doing low-level crowd work. They also had unique insights, the same kind of insights that they had we saw in the open call model as users of the system. There were also big downsides to this, this very naive approach. Oh, sorry, I'll just show you one example. Here's something that somebody built. You can see there's a QA status model right there. That dropdown was entirely built by a crowd worker. So not a particularly fancy feature, not something too advanced, but something simple and well-defined that somebody can construct in the course of a single pull request. Okay, but this approach is prone to a lot of failures. And if you've worked with interns before, you probably can guess what some of those are. The first one was that even though we had screened people for their expertise in being able to write good code, there are a lot of dynamics that occurred during software development that have nothing to do with your ability to write code and have a lot more to do with your ability to communicate effectively, to task out or predict the difficulty of tasks, and to collaborate directly with another developer or a product manager or a designer. None of these were things that in our initial approach we had actually tested for or screened for. And of course, the engineers who were actually working with these developers didn't know exactly how they should be managing an intern. And so there were a lot of examples of places where the net time that was taken was not accretive, but it was detrimental. The 2 folks working together spent more time than just the engineer having done the work themselves. So there were also issues, of course, where the pull requests were not accepted. People would make the code request, and the engineer would say, well, this is not a priority. We're going to look at this some other time when I finish my own work. So these are things that, at least with this naive approach, we encountered in not surprising ways. Some more surprising outcomes were that crowd experts would work too much. This was the first time they'd done any sort of software engineering work. They didn't want to let go of it, and we saw a couple cases where people would just work 60 hours, 80 hours, trying to do a really good job, but that's not really an effective way to build good product. We also had complaints about people not following code styles, complaints about people who were not necessarily following conventions, even if they were writing code that was technically correct. They wouldn't adapt to the natural code style of the company or things like that. So it was not too different from what you might get from hiring a brand new junior engineer straight out of school. And in retrospect, that's not terribly surprising. So this was effective once we had gotten past that initial onboarding phase. So once we had ramped the coder, once we'd corrected them on a few instances of coding style, communication style, we got this model to actually work. It was eventually efficient. So we carried out a series of tasks to measure what the joint output looked like. The first time we did this, it was not accretive at all. By the time we figured out the model and we had the folks working together in sync, the combined team of senior developer plus junior assistant got about 1.5x the output of a single engineer. So that was pretty good. That took a little bit of heavy lifting on our part to try and train people, but that dynamic, I suspect, could be implemented in a more efficient way. Okay, so some big challenges that I think will be resolved in the near future or should be resolved for the near future. First one is security and onboarding. How do you share data sets with crowd workers like this? We had ways around this by creating limited data sets that simulated the sensitive data that we wanted to hand out. I think if you wanted to do this in a larger organization, it would be a little trickier. And there's a question of how you'd protect against this. Crowd workers were sometimes less flexible than we wanted them to be, or more flexible than we wanted them to be in terms of trying to fit them into a streamlined production flow. So we'd have schedules, ship dates, roadmaps. Crowd workers could be assigned stuff from those items, but if it was critical path and the crowd worker decided to take a day off, well, that would have interfered with our business. So understanding how to remediate that's another interesting open question. We saw an interesting trend where people didn't follow the roadmap. They'd pick up something they thought was more interesting. So that was something that we'll likely need to, we would need to address. But of course, it was interesting that we could actually crowdsource contributions to a crowdsourcing platform, right? We found that crowd members could contribute usefully to production code in a crowd system. And as long as you're careful about product management and you have good communication, you can make this work. And that close support that you get is pretty similar to what you need from an in-house employee. One thing that we did add into the system eventually was redundancy. So if people could not do the work themselves, somebody else would show up and get the work done. That made this model more or less workable in a production setting. So that was work we did in 2015 and 2016. Since then, we've spun out a company based just on this idea, which is Crowdbotics. Yeah.
Because I missed it. Do you pay these people, and if so, do you pay them the same rates as your other crowd workers?
Yeah.
Or how do you
So we do pay them, and we pay them more than other crowd workers. So to give you a sense of what the numbers looked like when we were doing this at LeadGenius, our average worker would earn, and they were not in the US, about $4.50 per hour.
It always depended on what country.
It was all fixed. It was all dependent on the country they were in and their seniority within our system. If they were a developer in our system, we would pay them $10 per hour. And looking at global wages for software development, I don't think that we're too far off in a lot of geographies at that wage in terms of getting somebody who's good. So at Crowdbotics, we've looked at this question specifically around how much you should earn as a software developer living in various geographies. And to some extent, it matters a lot less because you are selling to customers in the US where software development services are at a premium. But in geographies like Kenya or Lima, Peru, earning between $10 and $20 an hour is a reasonable freelancing rate for a software developer.
I'm curious whether besides the quality of the output you got, the quality of the experience for the worker being very different. In this later case, they're getting almost a mentoring relationship, which has real value to them, as well as just somehow a better job. Who wants they can't work as a cog in a machine versus having some relationship. So did that come out in any way?
Yeah, so we've seen this a little bit we saw this a little bit at LeadGenius. We see it much more now at Crowdbotics because we think just about the developer question. At LeadGenius, people just wanted a shot at getting a chance to be a professional coder in some respect. They didn't necessarily know that mentorship or the experience of working in the team would be the big value. At Crowdbotics, when we talk to our community today, we hear very, very commonly that the interest is in working with an interesting team of people to develop some set of skills and to get experience and exposure to different styles of building software, which is something that they find appealing. We also play some tricks, which we can talk about in the discussion, around providing new opportunities for people to promote the ideas that they're learning with us in their communities. So I'll give you the punchline on Crowdbotics. So this model worked well enough at LeadGenius that we spun it out as a new company. We ended up building a whole new platform based on work we'd done after that point. We figured out ways to find and curate communities of coders, to figure out how to get these guys to collaborate via software, and to help us write software. So Crowdbotics as a company exists right now to use crowdsourcing to build software. The model works. I'll show you some examples. Basically, the idea is that we spin up instances of Slack and integrate with GitHub directly, using Upwork behind the scenes to track time management, to deploy software engineers really quickly into new organizations. So the model that we use today at Crowdbotics is a master apprentice model. That model turned out to be the best and most effective. Customers appoint a product owner or a product master inside the teams. They get a bunch of developers who show up to work for them, and then they can add 1 to 4 developers per engineer they've got in their team. So it's sort of this acceleration framework that they can build code a lot faster. And it's live. It actually works pretty well. Developers are pretty good and pretty cheap. The reason they're pretty cheap is that we're sourcing from geographies that are typically low cost of living. That number is the low end of what we end up charging. Sometimes customers end up paying up to $50 or $100 an hour, depending on the skill of the worker, and depending on where the developer is actually based. And all the communication we do today is either via the product, via Slack, or via GitHub. I'll show you some examples of the actual transitions that are actually produced. So here you can see this is the kind of interactions that our customers have. I'll give you a couple more examples. Developer will implement something based on a design shown by somebody else. So at the left, you're seeing there a sample of a task somebody gave to the system where they said, here's an interface I like, can you reproduce this for me? And there at the right, you see that there is a interface that was produced in the course of about 4 hours with the same interactions in place. There are some differences, of course, and I can talk about why those differences emerge and how you can remediate that, but they're not super difficult to eliminate. And then here's behind the scenes what the process looks like. So here you can see what a developer actually produced while they were actually constructing this. So this is an action plan that was designed by the Crowd developer based on the task that was given to them. And this was not guided by software. This was guided by the developer's own planning process and the templatized structure that we impose on the system. So there's steps in here that the developer had to think through herself in this case. So looking at the assets, trying to reproduce them, pushing your code to GitHub, and so on.
Intermediation, right? So if they're just dealing directly or like Slack, that if there's a decent margin spread, that they don't have to just bring it on.
Yeah. Well, so I'll give you, I guess, 2 answers, right? To the extent that we are creating value for our customers, it's okay if we get disintermediated, right? Because if we found a great developer and that developer is a great match for the organization, fantastic. The customer pays us a small fee and then they go and get to keep the developer forever. But in the short term, in the medium term, we have to eliminate that through software. So right now we have a strong software interface that allows us to control that relationship in a way that is difficult to eliminate. In particular, a lot of the planning activities here that you're seeing are things that we want to impose into the structure of the system itself. And our margin spread is not that gigantic in every case, and so in many cases the value is bigger in maintaining the relationship with us. There was a discussion at lunch that's also relevant to this, which is we're a risk buffer and a trust buffer, which is important for the companies that we work with and for the developers we work with. So here you can see typical sprint board that's being produced by a developer while they're doing work like this. Okay, good. So I'll close. I think we have a couple minutes left. We can jump to some discussion. I'll close with a couple of open problems that I think are fun. First one is code security. So if you're looking at this question of how do you crowdsource software development, one of the big questions is how do you securely share code? How do you make sure that people who are getting it have very limited access and are seeing just the pieces that you want? So today we solve it in a way that is not software oriented. We basically screen our developers exceptionally thoroughly and make sure that they're very honest people, and we sign very strong ironclad relationships with them. That also reduces the risk of disintermediation. But it would be much cleaner to have a software solution for this, where we were virtualizing somebody's code base and then selectively exposing just the code that somebody needed to work on, so that we could operate with a much lower trust model. Haven't done that yet, but I think it's an interesting technical question. Second one is around task assignment. So you saw a structure here where we basically allowed developers to plan out the entirety of their day. I'd love to get a model where we can actually have people who are less technical use the software that somebody produces to appropriately produce a task list, right? So if I show you an interface, I'd love to get a task list like that out automatically that says, here's the different pieces you need to actually build a project like this. Of course, the third one, which I think we've talked about a bunch of times today in the various meetings and conversations we've had, which is how you can take code off the web and use them in a process like this. So there's code repositories all over the internet that we should be able to use to drop into this process to speed things up. I think we'll get to an interesting place by trying to inject some of that, and we'll do some of this work this summer. And there's lots of interesting, hard machine learning problems there, too, that are fun. Cool. So I think with that, we'll just wrap things up. We can skip that out and just go from here. So.
Thanking our speaker. And we do have time for a few questions, so floor is yours.
Just regarding the security problem, I think the way that most big companies solve it is by they don't even allow you to take code off their computers. Like anytime you work, you just assign into their instance or something. Is this something that you guys would be looking into? Just spinning up some Docker for a worker and then doing something like that?
So that's exactly the solution that we're thinking about, right? Is virtualizing the customer's code base and basically keeping it in a container that we can create, interface with, and eliminate. Doesn't solve the problem completely because somebody could always just read the code and they're learning something about it. But that's where software plus trust makes it easier or good enough.
So how do you deal with creative licensing if from the crowd someone takes a code from GPL or our GPL instead of Apache and they don't copy the header? Mm-hmm. How do you scan for that? That would essentially jeopardize the entire code.
Yeah, so we haven't implemented this yet, but we've thought about this problem. Right now, we tell people in advance what kinds of codes we want them to use or not use. And usually there are cases where it's enough to just emphasize that this is important. If you wanted to solve this at scale, we could pass all the code we produce through a plagiarism checker, which I think would solve the problem. Just check to make sure it's not matching any of the code from these bad databases. We haven't seen this problem emerge yet, though, in a big way. And the reason is that as long as people know not to use certain licenses for code, most code that's out there is pretty good to use for the kinds of work that we do.
Can you talk a little bit more about one of the results, the 1.5x increase? What's the baseline? How do you measure the output?
Okay, yeah, great question. So this was work that we did as an early experiment, and it was a fairly simple challenge, so maybe not tremendously scientifically accurate. But we basically had a series of activities, like a task list that somebody had to do, with story points assigned and estimation for each one of those activities. We measured how long it took an engineer to do it without a developer. We measured how long it took an engineer to do it with a crowd developer. So it's a pretty informal metric because we had, one example of each, but we saw a 1.5x speed up with a trained person working with a software developer versus a trained person working by themselves. Okay, so if you want to do this properly, I can point you at papers in the literature that have done this experiment correctly, and they have a good baseline and framework that can be used for doing experiments like this.
Who are your typical customers?
Most of our customers at Crowdbotics today are tech companies. Typical company is fewer than 100 people. They have a giant product backlog. They need to work a lot faster. We are brought in by the product manager. We end up working with their engineers directly, and people are happy with the fact that they get product built a lot faster. Big companies we haven't shopped to yet, although I think it'll be an interesting angle for us to look at in the near future.
The typical size of a project?
So we have seen variations here. It's funny because I thought in the beginning that the big use case for this would be sort of small, ongoing, intermediate work. For example, somebody has a bunch of new interfaces they want to put up on their product, which does happen, and people do like that kind of flexibility. We also saw a fair number of customers, though, who just said, great, you have developers, let me use them as much as possible. And they'll basically try and maximize usage of the system. So those two categories are the most common.
So in my experience, like the amount of effort you need to onboard someone is kind of an indicator of the amount of technical debt you have, right? So it's like if they don't know what's high priority, then that means your issue tracker is like not good. Like if they need if they're writing bad code, then like your linters are like not, your linting rules are not quite good, or like your unit tests and your code is like poorly documented, etc. So given that you're going for like small startups, which generally speaking tend to have like worse quality code, is that actually like the right match? Like I would imagine that like large companies that have like very good defined like very well documented code, like Google and whatnot, would probably be like the more optimum match for this kind of thing.
Well, I think one way to think about it is like this. To the extent that we make money at Crowdbotics by building software or building systems for our customers, there is more to be built at a company that has not yet implemented all of these rules, because we can build those processes for them as well. And developers, one of the nice things that has emerged from the fact that we are serving a lot of different clients with a crowd of developers is that developers are sharing best practices and imposing best practices in organizations where somebody installs Crowdbotics. So somebody might bring in Crowdbotics for a very small project, but realize, based on the recommendations of the developer they've brought in, that they need actually to start doing linting, or improve their test coverage, or start doing better sprint management. So in that sense, we're able to help people a lot more at these small companies, which is a nice place to be for us. I think if it works for these communities, it'll easily work at big companies. But the converse is not true.
Thank you so much.